Okay, I thought Olivia's example is perfect for today for Thanksgiving, and I want to show you how wonderful reusability with Excel is. So what I could do is set up one Excel spreadsheet that all I have to do is change numbers to work any hypothesis test about a proportion. So we know that we're going to have an X value, which is going to be the number in favor, which was 21 people. Then we're going to have N, which is our sample size, which was 36. And from there, we can calculate the sample proportion, which we call P hat. Whenever I want to calculate something in Excel, I start with an equal sign. I do click on 21 / divided by 36. So that's going to give me the proportion, the sample proportion that she asked if they eat turkey on Thanksgiving. So there is my sample proportion. My P comes from the null, which in this case was 70%. All right, so I have everything I need. So from here, what I typically do is then set up and find my test statistic. Your test statistic is based off of your data. So in this case, it's going to be my Z test. So equals, open a parentheses. In the numerator, I'm doing P hat minus P, close parentheses, divided by the square root of P. So I'm going to open another parentheses, P times, open another parentheses, 1 minus P, close that one, so that's the numerator, and then divided by N and close the square root. So all I've done here is I've taken the square root of P times 1 minus P divided by N, and I press enter, and that is my test statistic. Usually we like to round these to 2 decimal places because you're going to see if you manually look these up in the table, that's how the answers are given, but it doesn't matter. Okay, we can put a couple more decimal places here. All right, so there's 2 ways to figure out what do I do now. Do I reject the null or fail to reject the null? You either have the critical value method or the p-value method. I tend to like the p-value method better because the p-value is just the probability I would expect. If this is really the null, I would expect to get 21 out of 36. So a p-value, pretty much everybody can understand because it's a probability. So how you find a p-value is you either look your test statistic up in a table, or you can use Excel. Now, if you have the older Excel, you're going to use norms.dist, and then you just click on this value. If you have the newer Excel, you'll see it's norm.s.dist, and then you have to put comma true. So when I hit enter, I get this p-value. Now you have to be careful because what this p-value is only half of the probability. We're assuming this is a two-tail test, right? We don't know if they eat more than 70% or less than 70%. So if it's a two-tail test, it's pretty easy to get the actual p-value. You just simply multiply by 2. So this would be the p-value. All right, so let's go ahead and over here so we know what these mean. This would be 1-tail and this would be 2-tail. Okay, because our problem could change. Like I said, the whole point of this is reusability. So then she told us that alpha was 0.10, which of course, as you can guess, if it's 2-tail, it's going to be whatever alpha is divided by 2. All right, so the rule is if the p-value, because this is the probability we believe the null, so we would like this to be higher than alpha. If the p-value is greater than alpha, we do not reject. If the p-value is less than alpha, we reject. So it's kind of cool in Excel. They have an if statement, and I'm going to tell Excel to give me the answer. So equals if Remember what you just heard me say. If the p-value is less than alpha, comma, put in quotes, I want it to print reject. Otherwise, comma, do not reject. All right? So when I hit enter, I think what's going to happen, it should say reject because the p-value is certainly less than alpha. So yep, it says reject. So let's highlight that because that's important. Let's highlight that's important. And then of course our p-values are important. Now for the two-tail, I'm going to do the same exact thing, but I'm going to compare this to this. Here's where you love Excel. I can copy this by grabbing that corner straight down. And watch what it copied when I double click on it. It actually moved down to the next cell. So now it's checking the two-tail. So it depends on, notice this one depended on, was it a one-tail or a two-tail? Because we got two different results. All right, so the p-value method, like I said, is kind of what I prefer, but a lot of students like to look up also the critical value. So the critical value is based off of my alpha. Okay, maybe we should put this over here because it kind of makes sense. The one tail and the two tail, critical value. Critical value. So it's based on looking up alpha in the table. Okay, so looking up whatever alpha is in the table and then comparing it to our test statistic. So guess what? Excel has a function, so I can use equal norm SINV. Again, if you have the newer Excel, it'll be norm.SINV. Notice it wants the probability, so I just click right there. And this would be my critical value if I'm doing a one-tail test. So I can still see I'm going to reject because my test statistic does fall. It's more negative in that critical region. All right, let's do, oh, well, remember my little copy straight down? So what this one did is it did the norms for the two-tail. So notice here, this critical value, this test statistic does not fall in that critical region. So this is pretty cool because it allows you to create one. Now I can just save this and say, okay, well, what if Olivia came back and said, oh, no, I'm sorry, I wanted to do 0.05. Now watch when I hit enter, everything updates. Now nothing over here changed because she didn't change anything over here. All right, let's go back and put the 0.10 that she said. Now let's say she goes and gets another sample of 36 people, and in this sample, only 14 out of 36. So watch all these numbers change, your p-hat, your test statistic. Now, whenever you see something like this is actually called scientific notation. That means take that decimal and move it 5 places to the left, or you can right-click and format the cells for a number and give me decimal places. Well, look how small these p-values are. So you would expect to reject, right? If you're saying 70% eat Thanksgiving turkey, but her test here, only 14 out of 36. So this is the beauty, I mean beautiful, right, of Excel, because I have created my own template that will allow me to work. I can go in and work every single one of your proportion problems right now by just changing these values and that value, and then of course alpha.